In this video, let's understand content-based filtering in a simple, practical way. We'll see how recommendation systems use item features, compare content-based and collaborative filtering, explore vectors and similarity metrics, and finally look at the pros and cons. Along the way, there will be quick quizzes so you can check your understanding. Content-based filtering is a recommendation approach where the system suggests items based on their features. So if a user liked certain books, movies or articles, the system looks at the characteristics of those items and finds similar ones. In simple words, it recommends based on what the item is like, not mainly on what other users did. There are two major recommendation styles. Content-based filtering focuses on item attributes such as genre, author, director, or keywords. Collaborative filtering, on the other hand, groups users by similar behavior and recommends what similar users liked. Many real systems, like streaming and e-commerce platforms, combine both methods into a hybrid recommender system. A content-based recommender mainly works with two profiles. First is the item profile, which contains the features of an item, like genre, release date, author, or metadata. Second is the user profile, which captures user preferences through likes, dislikes, ratings, searches, and past interactions. The recommendation engine compares these two profiles to predict what the user may like next. Now, let us look at this in a simple table format. Content-based vs. collaborative filtering. Main differences in how recommendations are made. Here is the core comparison. Content-based filtering depends on item features and metadata, while collaborative filtering depends on patterns across users. Content-based systems are usually easier to explain, because you can say a movie was recommended due to genre or actor overlap. Collaborative systems are often better at discovering unexpected items because they learn from similar users. A very common way to represent items is as vectors in a feature space. Imagine books described by features like children's literature, adventure, and Bildungsroman. Each feature becomes a dimension. Then each book gets values, often 1 or 0, depending on whether that feature is present. Once items are placed in this vector space, similar items appear closer together. Now that we've covered core concepts, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. What does content-based filtering mainly use to recommend items? The correct answer is item features. Content-based filtering recommends items by looking at their features or metadata and matching them to user interests. Question 2. What does collaborative filtering mainly rely on? The correct answer is user behavior patterns. Collaborative filtering groups users by similar behavior and recommends items liked by similar users. Question 3. In a content-based system, what does an item profile contain? The correct answer is the item's features. The item profile represents the item using characteristics like genre, author, keywords, or other metadata. When we plot item vectors, distance becomes a visual clue for similarity. If two books sit very close in the feature space, the system treats them as similar. If two items share exactly the same represented features, they may even land on the same point. But remember, the result depends heavily on which features we choose. Add a new feature, and item positions can shift. Once items are represented as vectors, the system needs a mathematical way to compare them. Cosine similarity checks the angle between vectors, so a higher score means greater similarity. Euclidean distance measures straight line distance, so smaller distance means more similarity. Dot product also considers vector magnitude, which can matter when item strength or popularity differs. After building user and item representations, the system can train a model for a specific user. It uses items the user already liked, rated, clicked, or purchased as training examples. Item attributes become inputs, and user behavior becomes the output to predict. This helps the model estimate whether the user will like a new item and then recommend it. Now that we've covered vectors and metrics, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. In vector space, What usually indicates that two items are similar? The correct answer is, they are close together. In content-based filtering, items that are close in vector space are treated as more similar. Question 2. Which metric measures the angle between two vectors? The correct answer is cosine similarity. Cosine similarity focuses on the angle between vectors, making it useful in high-dimensional spaces. Question 3. Which metric becomes smaller when two items are more similar? The correct answer is Euclidean distance. For Euclidean distance, a smaller value means the points are closer, so the items are more similar. One big advantage is that content-based filtering can handle new items better than collaborative filtering because it does not need lots of user ratings first. If the item's features are available, it can already be recommended. Another strong point is transparency. The system can explain a recommendation using interpretable features like shared genre, actor, author, or topic. The main limitation is feature limitation. If the item profile misses something important that the user actually cares about, the recommendation may not feel relevant. Another issue is over-specialization. Because the system keeps recommending items similar to what the user already liked, it may fail to introduce fresh or surprising options. Recent research suggests more dynamic approaches, including reinforcement learning, where recommendations update continuously based on user feedback like clicks, skips, and purchases. Now that we've covered pros and cons, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Which cold start case does content-based filtering handle relatively better? The correct answer is new items. Because it uses item features, rather than waiting for lots of interactions, content-based filtering can work better for new items. Question 2. Why are content-based recommendations often easier to explain? The correct answer is they use interpretable features. The system can point to shared features like genre, keywords, or actors to explain the recommendation. Question 3. What is over-specialization in content-based filtering? The correct answer is showing only very similar items. Over-specialization means the system keeps recommending items too close to past preferences and misses novel discoveries. That's the full picture of content-based filtering. If you understood how profiles, vectors, and similarity metrics come together, you've got the main idea. Keep exploring recommendation systems because this is one of the most practical applications of machine learning in everyday digital products.